Hello everyone. Today we'll be going through very important aspect of differentiation in which we are finding coordinates of turning points, which is a maxima and minimum point of a curve or a function. So we will be taking the functions at different points and we will be finding the maximum and minimum for that one. So first of all, we will define turning points. So before defining the turning points, I just want to mention that today's topic is included in most of the major examination boards like IGCSE, GCSE exams, A levels, and Cambridge Edexcel and other boards also. So you will have to carefully go through this one. We have already uploaded one differentiation video in which we have covered basics, and in this video we will be covering turning points. So go through this complete video, and after this video we will be uploading other videos on differentiation, maybe 4 or 5 more videos in which we will be covering, like for example, differentiation by AB initio method or by definition, and also second order derivative, plus we will be covering the increasing and decreasing functions as well. So in this video particularly we are covering turning points, which is maxima or minima. So what are the turning points? The function is not constant at all locations, so it is increasing or it can be decreasing also. So turning point is what? A turning point where a function changes from an increasing to a decreasing function or vice versa. That point is known as turning point. So in this graph, if you check, this one is the maximum point and this is the minimum point. So x value will be maximum at this point and minimum at this point. So these are basically the maximum and minimum of this function at these points. And if you see, this is point of inflection. So what is point of inflection? Point of inflection is where the function is remaining constant. It's not it's having same value. So horizontal line, if you see, this portion of the function is horizontal. So in the second graph which I have given for you, this one, this is having maximum point. Maximum point is having a zero gradient. If you see, this is maximum point which is having zero gradient, and minimum point also having zero gradient. But the difference is that to the left and right of the zero on these, this is maximum function. Both sides are from is moving from positive to zero and then negative. In case of maximum point, it is gradient is moving from positive to zero and then negative, whereas in minimum point, gradient is switching from negative to zero and then positive. So this is the maximum and minimum point. Then points of in fact inflection also, these are zero gradients. This one zero, this one also zero. These are points of inflection. And before point of inflection, it can be positive, and after also it can be having positive gradient. So in this example we have seen that gradient of the function before and after both are positive, but only at point of inflection it is zero gradient. Whereas in this section of the graph, before and after gradient are negative, whereas point of inflection is having zero gradient. So this is about the point of inflection. So further we will understand from these two diagrams which I have inserted here for you. The gradient of a curve is 0. Gradient of a curve is 0 at turning point. This is the point which you will have to keep in mind. And a turning point can be either maximum or minimum. So turning point can be maximum or minimum, and this both maximum and minimum points, their gradient will be 0 in both cases. So this is at a maximum point, the gradient changes from positive to negative, whereas at the minimum point, the gradient changes from negative to 0 and then to positive. The same thing, this is with better explanation. These drawings are showing better explanation. Then to find the turning points of a graph, what will be our strategy, how we will be dealing questions in exam. If they are giving a question, this is a function, and find the coordinates of the maximum point or the minimum point. So what we will be doing, we will be finding the gradient dy over dx and then putting that gradient equal to 0. This is how we will get x value, x coordinate of the point. And that x value we will be replacing in the function to get y value. And this is how we will be getting the coordinates of the turning point. Now, I have summarized finding the turning point steps. Like, for example, we can summarize it into three steps to follow. If, for example, if this is the question which is given, like y is equal to, so I will be writing here y is equal to x squared minus 8x and plus 3. Suppose this is the function provided and we are asked to find the turning points. So our first step will be that we will be finding derivative dy over dx. And derivative, how to find derivative, we have already uploaded one video. You can, if you are having issue, you can go through that video in detail again. And here I am just writing directly, so because I have already given explanation. So dy over dx will be what? 2x minus 8. So this will be derivative, constant derivative, is equal to 0. So derivative of 3 will be 0. Now, this is the first step which we have done. Second step is solve dy by dx is equal to 0. So dy over dx we will be putting equal to 0. This implies what? This implies 2x minus 8 is equal to 0, which implies 2x will be equal to 8 and x will be equal to 8 by 2, which is equal to 4. So x value we got, x is equal to 4. This is the value which we got. Again, what we have done, we have taken the function and we have taken the derivative of that function and put that derivative equal to 0, and we got x value as 4. Now the final and the third step is use the original equation. What is the original equation? This given equation. To find y when x is equal to 4, we got this x is equal to 4. So this y value, this x value, we will be replacing in y, and we have y is equal to x squared minus 8x plus 3. To find y coordinate, we will replace this x value in this one. So our y will be equal to 4 squared minus 8 into 4 plus 3. And we can solve this one. Basically we can solve this like 4 squared, so 4 squared minus 8 into 4 and plus 3, so this is resulting to minus 13. So minus 13, y is equal to minus 13. Now we have this y value, we have x value. Our turning point will be what? Our turning point, we can write x value first and y value second. So this will be our turning point. this is how we are finding. So I have summarized this into easy 3 steps. First step will be taking derivative dy over dx. Second step, putting that derivative equal to 0 and solving it, and then you will get x value. That this x value you will be placing in the original equation, and you will get y coordinate also. Now for practice, I have summarized, I have basically given these 9 questions. So this will be a nice practice. You can solve this, and I will be solving some of the questions. Like for example, I will solve this G part. So this G part we can go through. This is G part. So the same strategy. What is G part? G part is y is equal to 3x squared plus 48x minus 2. So first step, taking derivative, so dy over dx will be equal to 3 into 2 will be 6x, and plus 48, and derivative of minus 2 is 0. So this will be our derivative. Now after taking the derivative, we'll have to put dy over dx equal to 0. So our 6x plus 48 will be equal to 0. This implies 6x is equal to minus 48, and x will be equal to minus 48 over 6, and this will be equal to minus 8. Now our x value is minus 8. We can find y value. To find y value, we have to replace this one. This is our x value. Now this value we will be replacing in the original equation, and original given equation is y is equal to 3 into x squared plus 48x minus 2. In this one we will be replacing x is equal to minus 2. So 3 into minus, sorry, not 2, minus 8. So minus 8 squared and plus 48 into minus 8 and minus 2. Now we can solve this by the help of calculator. So 3 in brackets minus 8, and this will be squared, and plus 48 multiply by minus 8. This is also done. Then minus 2, and finally we can check. This is minus 194. So minus 194. This will be our y coordinate. Now we got x and y coordinate. Just we have to write the point minus 8 and minus 194. This will be the turning point. So this is one question I have taken. This is a minimum point which we found. We can take another part, like for example C part I'm taking. So rest of the questions you can practice. Rest of the questions, if you are having some doubts, I'll be here to help you. So you can always contact. So y is equal to 2x squared plus 4x plus 1. Keep in mind, for these questions, algebra is very, very important. And you know that algebra is a major portion of your exam. So you'll have to practice simplification of algebraic equations, simplification of algebraic expressions and equations is very, very important for this one. For example, this one we will be replacing our first step dy over dx is equal to z. We will find first. So this will be 4x plus 4. This will be the derivative. Then we have to put dy over dx is equal to 0. These are simple and straightforward steps. So 4x plus 4 is equal to 0. 4x is equal to minus 4. This implies x is equal to minus 1. So x is equal to minus 1 will be the coordinate, x coordinate. Now to find the y coordinate, we have to replace this x is equal to minus 1 in the original equation, and our original equation is y is equal to 2x squared plus 4x plus 1. Now we will replace x is equal to minus 1. So 2 into minus 1 squared plus 4 into minus 1 plus 1. Again, I'm telling you that derivative, I'm not explaining how basics of derivative. So you can go the other video which I have uploaded. You can go through that one, and that will be explanation for how to take derivative. So this one is 2 into minus 1, and this will be squared, and plus this will be 4 into minus 1 and plus 1. So 2 minus 1 squared plus 4 minus 1 plus 1. Okay, and this will be equal to minus 1. So our value, this is minus 1. So y coordinate is minus 1. We can write now the turning point will be our coordinates minus 1, and y value is also minus 1. So this will be our turning point. Hopefully you understood this. So we have done, out of 9 I have done 2 questions. The rest of the 7 questions is like your homework, your assignment. You can do this and you can practice in the similar way. And now we can move to the next section, which is coordinates of the maximum point. For maximum points also, our strategy will be same: to find the derivative, replace derivative equal to 0, or put derivative equal to 0, and find the x coordinate. After finding x coordinate, replace in the original equation and get the y coordinate. Like for example, I will take question number, mostly I'm taking G part from the randomly, basically I'm taking, so that you can have like other, you can practice. So y is equal to 4 plus 24x, 24x minus 3x squared. So this is our G part. Uh, Again, no, I think so you must have memorized 3 steps. First step is what? First step is taking derivative. So dy over dx. dy over dx is derivative of constant, which is 4, will be equal to 0, and derivative of 24x will be 24, and derivative of minus 3x will be minus 6x. Minus 3x square, derivative will be minus 6x. Now we have to replace dy over dx equal to 0. So this implies 24 minus 6x is equal to 0. So 6x is equal to 24, and x will be equal to 24 over 6, which is equal to 4. Now x coordinate we got is 4 for this maximum point. Now we can replace this in the original equation, which is this one. So y is equal to 4 plus 24x minus 3x squared, and this will be 4 plus 24, x value is 4 minus 3 into 4 squared, and this one we can solve by the help of calculator. So this will be 4 plus 24 in bracket will be 4, and minus 3 into 4, and this will be whole squared, and this will be equal to 52. So y value is equal to 52. We got the coordinates of x and y. We can write the point, and the turning point will be 4 and 52. These will be the coordinates of the turning point. We have done one of these questions. It will be better to solve one more. So I'll be taking, like for example, this, and this is C part, and you will see that in this part you will require to simplify the equation. So this is C part. So we'll have to multiply basically first. 7 multiplied by x will be 7x, and 7 multiplied by minus 2 will be minus 14. Then minus x multiplied by x will be minus x squared, and minus x multiplied by minus 2 will be plus 2x. So what we have done, we have multiplied 7 with x, then 7 with minus 2, then minus x with x, and minus x with minus 2. This is the order multiplication which I have done. Now we can take the derivative. Next step is taking derivative. Otherwise, before taking the derivative, we can rearrange it. Y is equal to minus x squared and x value will be plus 9x minus 14, and now we can take derivative. Dy over dx will be equal to derivative of minus x squared will be minus 2x, because par we are pulling first, so par in this case is 2, so negative 2, and x plus derivative of 9x is 9, and derivative of minus 14 constant will be 0. So now next step, dy over dx will be replaced equal to 0, and this implies minus 2x plus 9 is equal to 0, which implies 2x is equal to 9. So x is equal to 9 by 2, which is equal to 4.5. So x value is 4.5. This is our x value. Now, after finding x value, you know we have done a lot of questions. So you know what we have to do. We have to basically solve, we have to replace this value in the original equation. And original equation is what? This is our original equation. We can take this as original equation, this one, not this one, this is the arranged one, or we can even take this question 7 minus x into x minus 2. So I will be replacing in the question, so y will be equal to 7 minus x mean 4.5 and 4.5 minus 2. So this is basically the question, y is equal to this, and we will be replacing in this one. And if we replace in this, really I don't like this 2, so I will be rewriting this 2 neatly like this. Okay, good. Now this one, now we can put bracket like this, and 7 minus 4.5 bracket close into the second one will be 4.5 minus 2, and this one, and this will be equal to what? Decimal value will be 6.25. So y is equal to 6.25, and we got this value of y. And now the final step. Final step is writing the coordinates of the turning point, which is 4.5 for x and 6.25 for y value. This is done. We have done basically today differentiation, utilization of differentiation for turning points to find the coordinates of the turning points, and we have done like maximum points. We have done 2 questions, other 7 are your homework, you will have to do that. And for minimum also I have done 2 questions, rest of the questions you will be doing. Plus we have done the rules, the basically 3 easy steps which you can follow and find the turning points. First step, again, what is first step? Finding differentiation. The second step, you have to put differentiation equal to 0 and solve it. You will get x value, x coordinate. After getting x coordinate, replace that x coordinate in the given function, and you will get y coordinate. That is your turning point. That's all we have done today's job. I have explained basically graphically these things, and there are other videos, incoming videos, in which I will be explaining increasing function and decreasing function. Plus, I will be taking separately all the differentiation rules in one video. And plus, I will be taking second order derivative, that will be for AS and A levels. Second order derivative. Plus, I'll be taking the utilization of second order derivative. And also, I will be very importantly covering another video for AS&A level, which is derivative by A, B, initio, or definition, by definition, right? So hopefully you will be enjoying videos. I will be waiting for your positive comments, and recommend these videos to your friends and class fellows. Also introduce this to your respected teachers. And thank you very much for watching. Take care. Bye.